In the previous lab, you learned that work is done when a mass is moved in the same direction of an applied force. How quickly that work is done defines power. In this lab, you'll compare the power generated when the same work is done over two different periods of time.
Read the introductory paragraphs and pay particular attention to both the definition of and the units of power. Go to the bottom of slide 1 and complete the predictions.
Slides 2 and 3 instruct you to use this setup, in which a 500-gram mass is suspended by a 1-meter string on a rod. The timer started, and then I start winding the string up, raising the mass against gravity until the mass gets all the way to the top, at which time I will stop the timer.
Slide 3 gives you the equation for power, which is measured in watts. 1 watt is defined as 1 joule of work done in 1 second. Remember, because 1 joule is equal to 1 newton times meter, mass must be converted to weight in newtons. To do that, it must first be converted to kilograms. 500 grams equals 0.5 kilograms, and 0.5 kilograms times 9.8 meters per second squared equals 4.9 newtons, the weight of the 500-gram mass. 4.9 newtons is the force that must be applied to lift the 500-gram mass.
I will now see how long it takes me to lift this 4.9 Newton object 1 meter. And that was 20 seconds.
The time of 20 seconds is entered into the data table, and now both work and power can be calculated.
I'll now attempt to do it in a different amount of time. And that was 10 seconds.
This is entered into the data table.
You can calculate the work and power for this faster time and then finish the questions on slides 3, 4, and 5.